Yo, yo, yo. I'm back with another stream, another grass, or a continuation on the grass shader implementation. Good morning, Harukanan. So, I think the grass itself is in a pretty good state right now, or so far. What kind of options do we have? We have grass bottom color, grass top color. That's one thing we're going to implement today. We're going to implement colorization of the grass, and I'm not entirely sure just yet exactly how I want to do this. So this, yeah, let's get to that one a little bit later. And then we have grass proportions. It's spaced a little bit weirdly here, but we have grass bend bounds, how much you bend it, but it's like it's an offset in tangent space, the y direction in tangent space. I don't know if this is the best way to do the bending. I mean, the bending looks fine unless you go overboard with it, right? And what more do we have? We have a grass bend exponent. So like if you want it to be a linear blend, quadratic, and so on. We have width, which is randomized between this one and this one. And then we have width decrease multiplier, like how thin do we want it to be on the top, so, or how much do we want it to decrease with. I don't know if this is the best name for it, but maybe it is. So if it's 0, we don't decrease it at all. If it's 1, we decrease it to 0. And then we have the exponent here as well. Like, do we want to do it linearly or not? And I do like the grass when they're not as pointy on the top, at least from a distance. What's up, long name? Would be extremely nice. To fire one up right about now. So we have width, and then we have height. Height we don't do that much with. We just give height, or the height of the grass is a value between, or the height of the grass is between these two values. Then we have grass subdivision, so like how many times do we want to subdivide the grass. 1 gives grass like this, and the higher we go here, the better it looks, but also the more expensive it gets. Then we have a subdivision for the entire plane, so a subdivision of 1 is just the original plane. Subdivision of 2 tessellates the plane, and so on. If we go to 3, we already get a pretty nice lawn, I would say. It's pretty nice, right? Could go even up to 4. That way we can make grass that is not as high and it still looks extremely good. Look at this. Do we have... Okay, so grass right now is not affected by shadows, and I don't think it's affected by lighting either. So shadows I knew, lighting might have to do with the normal actually. We don't generate the normal, so I think we should do that when it comes to the lighting. So that's one more task to do. Oh, I love the look of this. I especially like how the outlines around the grass here. I'm a big fan of this. The idea is also to, so you generate a base color on the grass ground plane, so this underlying here, and then the beginning of each grass straw has the same color as the underlying plane here. That way you hide these lines and it will just look a lot better overall. I'm extremely happy with how the grass looks so far, and there's like a lot of ways to improve it even further. Okay, so grass, straw, grass, normal generation. Although geometry shader output. The question is, do we need to handle all the lighting ourselves? Maybe we do. Could probably rely on some functions in the universal pipeline. So the shaded library here. But so like tags, light mode, universal forward. I think this would, usually this calculates the lighting for us. But the question is it different this time around since we have a geometry shader in the pipeline? I want to test this really. So right now we don't generate any normals for the vertices here, but we also let's see here. I need to, let's see what internet says. HLSL Unity geometry shader lighting. Let's test this one. Okay. No answers. Okay. Ooh, let's check this one out. No light map support. Okay, with that, no shadow mask support. Standard geometry shader. Okay, here we go. Okay, construct normal. So if we do a normal, varying. I still think that we can maybe still rely on this one actually. I think. Are actually deferred. Are we working with geometry here? Build quad. Yes, we do. Okay, let's see. They do light mode forward base. Normal. I'm not pro, what's up? How are you doing today? What I'm tackling today is, I think we're gonna start with grass normal generation and grass lighting. I think so. We're gonna add lighting to the grass, or see if we already have it. And to do that, we need to add normals to the grass. So these two things first, and then we're gonna do the color generation for the grass. That's what I'm tackling today. Fog as well, that's true. Oh, it's gonna look amazing, I think. I haven't really decided yet how the environment or the background will be shaded in my game. It will be somewhere between pure cell shading and physically based rendering. Just haven't exactly decided how, like, where on this spectra I want to position myself. But I know that Unity has some lighting functions we can probably use. Is your grass a shader? Yes, sir, it is. So we're generating it with a geometry shader. Let's see here. Let's add a normal then, but need to add normals here as well. But this one is easier, I think. Or actually, is it? We should already have a normal here, I think. So we get a triangle here. Let's see, we get domain shader output. Yeah, we have normal in world space here. And do we want normal in world space here as well? Maybe we do. I don't know what's preferable to work with. In my cell shaded lit, I work with normal in world space. But we also work with this. Let's go with normal in world space then. And we already have it here, we just need to do, I wonder, position. I think I want to do and normal here. Oh yeah, position 1 then. There we go. And then we have a normal, we just need to assign it. So when we append something to triangle stream here, we use this one first of all. Position C as UV. Let's do it like this for now. So now we have these normals fixed. hard part is going to be to create these normals. But we do generate the transform world to age clip. Position left. Like we do generate these in tangent space, so shouldn't. Quick question, do you think it's a good idea to create rain using shaders, not talking about puddles? Yeah, I think it's a pretty good idea. It depends, so like if you create it by shaders, you will have a harder time making the rain appear to interact with the game world than you would if it would have been particles. Performance-wise, better? No, I would say so, but yeah, I think so. So we have a transformation matrix here which brings it from tangent to world, and we also have a random rotation on it. So I think if we just define the normal in tangent space, what is it, 0, 1, 0, is that the normal in tangent space? Good morning, Geralt. Is this in tangent space? That is local to the surface of the triangle, the local reference frame. They're all defined. Yes, okay, great. So then we should be able to do... let's try it. What's up, Cypher? So I think if we define the normals in tangent space, we can do it like... Well, keep it up, man. Good luck. Thank you, appreciate it. And good luck to you too. Hope you can get some nice rain effect. What's up, Justice Boom? Joe. I would like to be able to generate the normal like this. What bothers me is we're gonna have the same normal for both of these, so it would look something like float 3 normal mul, or is equal to transformation matrix. Not entirely sure this is correct just yet. Float 3 0 0 1. So just in the positive Z in tangent space, then we transform it from tangent space to world space and we rotate it. And let's go with this normal. I want to check how this looks as well. O.normal. And let's take a look here. So in fragment we do return float 4 and we do input.normal 1. So we just return the color of the normal, or the color as the normal. This one is in world space. Actually, I think we define it like this. Let's see how it looks. 328. Oh yeah. Yeah, that's wrong. Do we get another color if we do? Yeah, we do. So it's just an up vector right now, so 0, 1, 0. And if we rotate it, blue. Don't think it's because of this one, but it might very well be. Okay, so these normals are correct. They're pointing upward, the green one, and the red here. We want to flip it as well. Ooh, this is gonna be painful, I think, but let's see. But is this somewhat correct? Let's do this. Shader utils. Shaders, let's add a folder and we'll just do test shaders. I want to create a simple shader that just outputs the world normal for objects that I know have the correct normals, so we can use that one to debug with. I just think that seems like a nice way to do it. So let's create shader unlit shader. Normal world space shader. Fuck it, let's add a test materials as well. object shaders, test shaders. Oops. Vert. Okay, let's start and being let's start and name the vertex shaders and fragment shaders and so on the same in every program. Starting now. Make fog work. I don't care about fog. I don't care about this include as well, I don't think. I'm more a core kind of guy. App data. So let's call this one vertex shader input. I think that's the naming convention we went with. What's up, Thotty? What engine you using? It's Unity. Don't care about fog. Don't care about main text. Vertex shader output. Vertex. I like to... The more my shaders, the code of my shaders look like how I write my C#, the better. I used to be the kind of dude that wrote shaders like this and shorts like this and only small letters and stuff like that, but just becomes... I just think it's less readable, to be honest. Vertex shader input, and instead of V, do input. And I don't want to do any of these right now. Instead, I want to do... Okay, first let's decide the things we care about. We do care about position, and we're gonna name it, what is it? Position object space, right? Position OS. Vertex shader output. UV vertex. Oh, so they name it vertex. Let's go position clip space. Or yeah. And then I want float 4 or 3 normal, and we want it in world space. And I think this is about it. And then we're going to use some very nice helper functions from core. We're going to use get vertex position inputs and get normal inputs. Love these two. So output.position CS is equal to vertex input position. I'm not entirely sure about this name though, but so pretty much what this one does is it takes our position in object space and then it returns a struct with that position transformed into a lot of different spaces, and then we could just take the space we want like this. I don't know how optimal it is, but in this case maybe not that much, because we're gonna leave a lot of the position in different spaces unused. But I don't care right now. Output normal world space is equal to normal input dot normal world space. I think it is. Okay, and when it comes to the frag, let's do float 4 and fragment. Vertex shader output. I also like this naming. I don't know, vertex shader output, called input. It's a little bit weird, but I also like this. This makes it extremely clear that before this fragment shader, it's a vertex shader. So you don't have any tessellation shaders, geometry shaders, or anything like that. Normal VS and 1. I think that's about it. Macro redefinition, was that because we used HLSL support CG include together with this one? We don't anymore, so I'm just gonna hope that was a previous problem that we don't need to care about right now. Material world space, or actually normal world space material. Test. Okay, do we actually have some error here? Okay, we do. But why am I getting this if I'm not including? I'm not including this one anymore. So why does... Oh yeah, okay. So we want to do HLSL program, and could it be this one? HLSL. End HLSL. Beautiful. Invalid subscript normal OS. Where do we use that one? Here. Oh yeah, normal OS and tangent OS. Cannot convert from float 3 to float 4. Get further. Does normal tangent is tangent actually a 4? Maybe it is. Okay. Invalid subscript normal VS. Vertex shader output. Yeah, return output. Are we finally done? Yeah, I think we are. Okay, so let's add a cube. Actually, let's add a sphere. I think that's better. And normal world space material. What do we have here? Test materials, test shaders. Normal world space. Beautiful. Looks pretty good, I think. So it's pretty much this exact line we do here. So the grass straws are, so this one for instance, which is pointing in this, should it be blue? Yeah, it should be blue. And then we have purple. I guess it's okay. Like, it generates correctly by our implementation, but it's not a good implementation. So what worries me a lot is that, first of all, the grass straws has the same normal for each vertex. So if we take this one and bend it a lot, if we bend it like this, vertices here should have a normal pointing more downwards, right? So yeah, a lot of things needs to be fixed here. But when it comes to the initial direction, that seems to be correct at least. So that's good. So, how to actually generate the correct normals for this? How do you take into account the bend when you do the normals? We want to get so we generate 2 points. Okay, so there's a lot of different approaches we can take to this. So if we don't have any bend, if our grass looks like this, then the normal generation is correct now. Except for the fact that we currently don't support wait a minute, is this actually correct? It seems to be a bit off. Good morning, Love. It's going pretty good. this. I think it's correct, yes. It's just that, okay, so we have two problems. The bend is not taken into account when we generate normals, and we can't shade them like two-sided right now. So both of these sides of the grass straw will have the same shading. What we can, I think I'm gonna start by fixing that problem because I think that's the easier one. Probably gonna regret that. But we have a shader called Cell Shade Lit double-sided, I think. Or actually, we solve it in Cell Shade Lit with a flag here, double-sided culling. So in the fragment shader, we also send in a bool is facing is front facing. And if we're using double-sided flag, if the n is based on the facing variable, we flip the normal. I think, or I'm pretty sure, we're gonna get a issue, or we're not gonna get the correct result if we do exactly the same in this one. And that is because, let me show you this by the pretty drawings, or hopefully with a pretty drawing. And it's a problem related to how we generate the triangles in the grass straw. So let's do it like this. So when we generate the grass straw, we generate... Actually, we don't do this middle line here. That's true. We do it like this. So we generate this point, then this point, then this point, which means that 1, 2, 3, 4. When we create triangles from these points, we go 1, 2, 3. Or actually, we do 1, 2, 3, 4. This is how we generate them in this order. And when we build triangles from the vertices, that means that we build the triangles going 1, 2, 3. So, one sec. One, two, three. 5, 6. So when we build this first triangle, we go 1, 2, 3, which means that we have a clockwise. We're going clockwise for this triangle. When we build the second one, we'd go 2, 3, 4, which means we're going counterclockwise. Which means that, like, the two triangles making up one quad of the grass, or for like the two triangles that making up a quad of the grass, their normals are pointing in the opposite direction, I think. And so what we will get is probably, if we go a similar route as this, do is facing, is front facing, flip the normals, we're gonna see a pattern of, if I've understood this correctly, we're gonna see a pattern of blue, black, blue, black, blue, black, blue, black, pretty much. Or this is what I anticipate, at least. We'll see if that's actually the case. But it should be easy to fix nonetheless. So, or actually, let's see here. That might not be the case at all. I need to think about this one. We generate points and we add the normals to the points. Let's find out. What's up, Val? Valcant? How are you doing today? Let's just try it and see what happens, and then deduce if it's correct or if it's not, and why or why not. So nice to hear. Same here. Just doing some shader work, which I love. We don't want this flag. We don't care about this flag. We're always going to render the grass double-sided. We don't care about the tangent for now. Might want, like, I've been thinking if I want to include a normal shader for each grass straw. I think that would be very nice. I want to, let's see here, grass close up. Is this the best close up you have? Yeah, I wonder if I want to, like, do I want to display this middle line using a normal map, or is that too much? Like, so you can do grass straws that are a little bit, that visually are a little bit bent relative to the middle. I don't know yet, so we might need this in the far off future, but not now. So instead we're just gonna do this. Or actually, yeah. So float 3, and let's be explicit. Normal vs is equal to vs, otherwise so we pretty much get in here and we check, is this fragment is it facing or not? Like, is it facing is the normal facing the camera or not for this fragment? If it is, just return the input normal. If it isn't, return the inverted normal. And then we want to do normal vs here. Let's see how it looks. Okay. Yep. Okay. So what I thought would happen with the triangles for each quad did not happen, so that's good. We actually got the correct result. Perfect. So this one, although, yeah. So this we can see we can test with this grass straw here. On this side it has a normal of blue. Is it the other way around? And then we have red here. That doesn't seem... Is it like that for every grass straw? Yes, it is. Right? Okay, so the world normals for the grass straws seems to be inverted. Other than that, it seems to be working fine, I think. So did I mess this up? Here. If it is facing input normal, Is this the wrong way to do it? Normal in tangent space. 0, 1, 0. Or did I do it the wrong way in normal world shader? I don't think so. Is my transformation matrix wrong? I think I want to rename this one binormal as well. Real Gaming, what's up? Didn't I rename this one 175? Can you please run the game for me? Not right now, sorry. Why am I getting this issue here? Binormal VS 175. Okay, so here it's actually called bitangent. So maybe I do want it like that, but I'm a little bit... Binormal, bitangent. Let's go bitangent. Yes. Although cell shade lit. Tangent, bitangent, normal. So tangent to world. So this is how we create it here. X, Y, Z. X, X, X. Let's see here. So it's row column, so tangent, bitangent, normal. Tangent, bitangent, normal. Tangent, bitangent. Okay, so we create the tangent to world the correct way. The normal, however. Okay, so this could be what's causing the issue. What you on about, Real Gaming? This could be very well be the issue. But normal VS here. Ooh, okay. Yeah, okay, that's true. So here we just take the input and send it on. So why am I getting the wrong result here? Because if we compare to this one, I'm just assuming this one is right now. I think it is, yeah. Yeah, it is. So grass straws, instead of blue here, we should be seeing red. And on this side, instead of red here, we should be seeing blue. But that's not what's going on. So if instead we define the normals in tangent space by -1 here, we get the correct result. But that doesn't make much sense to me. Or if we could also do, if we just do minus here. If we don't add any random rotation, let's try that. I wonder if it's the rotation matrix that screws this up. So no rotation, still wrong. Unity normal in tangent space. What is the normal in tangent space? Roughly in the positive z direction in OpenGL. Usually viewed from plus Z direction. I would have guessed that this is actually how we want to define the let's try just tangent to world. No, that's definitely wrong. So positive Z for the normal is wrong. Only using the tangent to world is also wrong because we need the rotation as well. This is closest to the truth, but not entirely correct. -1 here. Not too sure about that. And if we do this, then we get red here. So then we get the correct. So, but yeah, just for some, of course. One sec. One sec. What? So we base tangent to world. The tangent. First of all, we base the tangent to world matrix only on the first input. So the first vertex, the first vertex. Is this something I want to fix, or don't I care about this? Oh, and actually I just, since the plane is bright green here and black on the bottom, that means that nothing here is wrong. So it's this. or this? Pretty sure I want to use the tangent by tangent and normal from the full triangle. So, and we should be able to just do it with barycentric coordinates, I think. So I don't know if this really matters that much, but float 3 normal world space is equal to interpolate barycentric I don't think this will solve it, but this will fix this one at least. A possible error. Oops. Yeah, this issue still persists. Am I doing this tangent by tangent normal? It's done in the correct way, right? Tangent by tangent normal. Tangent by tangent normal. All in world space. X, X, X. Yeah. Probably not the correct normal in tangent space. But gives the correct result flipped somewhere else. I have no idea where. Or could it be this issue? With the clockwise, counterclockwise. Probably to do with clockwise, counterclockwise generation of triangles when generating them. Maybe. That's the only reason I can see. Also a little bit annoyed with the fact that... fuck, is this not the correct way to do it? Like, maybe it should be 1 here. But like, this seems to work. And it even works if we flip this one now. So we have green and we have orange. It seems to be okay. What's up, Smack My Peach? How do you debug a shader? Usually in a similar approach as this, just outputting color values basically. That's the default way to do it, I guess, or the most basic way to do it. Because you can't really print stuff, you know. I don't know if it exists something new, modern, that allows for printing values and stuff like that from the GPU, but it didn't when I learned shaders, at least. So we debug it by outputting colors. Okay, so this is correct. I'm happy with these colors, I think. Although, am I seeing something that... No, it looks okay, it looks okay. Yes, it does. Okay, so the normal generation is correct. If the grass blades are not bent, but if we bend them, like we see that the normals are being generated as if they were straight, although we should see some form of gradient here going from, for this blue one for instance, we should see a gradient of going from, what is it, blue to darker blue. That might not have been the best example. But this one, for instance, I think we should see it going from black to green, right? So we're starting with normals in this direction, and then we're going up to normals that should be in this direction. So this one should have, yeah, it should start with blue and become lighter blue. And at the top it might even be closer to yellow. We should see a gradient at least. So does it exist an easy way to do this? So we generate points, we bend the points right about, we actually bend them here. So bend, multiply, random bend. So instead of doing like this, we take we construct a normal in tangent space, and then we transform it from tangent to world space. Do I want to do something with this one instead? Or could we do get normal from point in tangent space? I'm not sure about this one. Getting the tangent for oops. I'm trying to visualize this. So tangent space is pretty much just the plane we're working with. Could we do subtract this one from this one? One sec, I need to check one thing. This is take a look at a solution to this. Where do I have it? Actually, let's take a look here. When the blade curvature amount is set to 1, the blades of grass all face the same direction in tangent space, directly backwards on the y-axis. So this is the correct way? I'm not entirely sure. Maybe if it's counterclockwise. Let's see. Does this make sense? Bend, multiply, random bend. So we can bend with multiplier, random width, random height. Okay, so with multiplier, and then we can do float. We can do it like this. Do I want to... I wonder if I want to vary these two here. Maybe I do in the future. So we're going to hold on that one for a little bit. Bend multiplier. Random bend. So something like, and then of course normalize. I do see a gradient, which is good, but I don't think I see it nearly enough. Right. See it here, going from black to green. That looks pretty promising. Flute. Maybe it is correct. Actually think it is. I think it is. I want to make Can I make this make sense? So the default plane normal, and then I guess it's tangent and bitangent. For our plane. And we create a so like if tangent space was like this, it should pretty much, for a plane, I think the normal direction would, or like a position in tangent space here. I think correct. When we define the grass straws, we do it in tangent space. And the bend is the Y, so bend is upwards. Maybe it is correct. Up and down. I need to look into that, but I think we're getting the correct values. Like, I like what I'm seeing here with these going from black to green. I think it's about enough. Okay, so gonna add some notes here. In Unity, I don't know if they're using another, like, I guess the coordinate system that is used for tangent space might differ between, or no, it should only differ based on what I do or how I define the tangent space by what vertices, shouldn't it? But let's keep it like this, and we will see what I can find. And since we do this, interpolating the normal tangent and bitangent between the three different vertices, before we create the tangent to world matrix, I think double check normal generation when grass is generated in the middle of the triangle if it's fixed, and grass normal generation is probably fixed as well. So let's add some lighting to this, and then I want to do, so when we have lighting in place, I want to do color generation. I want to go crazy when it comes to color generation. But before I do that, I just need to run AFK real quick. So, be right back. back. Sorry about that. Okay, let's see if we can output just some gray color. Let's do grass bottom color. Let's add just a pure grass color. What's up, Ferda? Good morning. Color 0, 0. Let's go 0.5, 0.5. It's going pretty good, I think. How about you? How are you doing this morning? And let's just return, oops. Grass color here. It was actually a float 4, right? So I should be able to just return it. Is the grass you're doing all GPU based? Yes, it is. This one is, at least. We'll see if we will create some model based grass and foliage later on, but right now it's all shader based, so yes. Yeah, I've been a big fan of geometry shader based grass for a long time. Been wanting to do it myself, so I found a lot of good write-up and resources, which I'm leaning against, but it's going pretty good. Okay, so it's full gray now. Let's see if we can take some help from some Unity functions to properly calculate the lighting here. So I want to do I have this one starred on, let's see, Unity, GitHub, shader library. I want to see the source files. Common core, what do we have? Unity technologies, graphics, shader library, core HLSL. Beautiful. And I want to check shader library. We should have something called lighting.hlsl. What do we have here? We have lighting Lambert. So here we just need to send in light color, light direction, and normal. Lighting specular, lighting physically based, BRDFD data. We still need to send in data here. Raiden Shogun, what's up? How are you doing today? Do we have lighting physically based? Do I care about this? Here we actually have just something a light. Yeah, here we do vertex lighting. We just need position and normal in world space. This one, however, is so vertex light colors. This is per vertex. I would love a function much like this one, or this one, or this one, but you don't send in light data, but rather it's handled inside of the function. Wonder if we have something like that. Calculate blin fong. We still send in light. Universal fragment PBR. Input data, surface data. Okay, so what the fuck is input data and what is used by shader graph and other built-in renders? Can I rely on this one? That would be very nice. Although surface data, yeah, I want to check how this one looks, and input data as well. We could probably create these ourselves. Okay, this one, I would like to use this one, I think. Mix real-time and baked. So this one handles the real-time and baked as well. Main light. But does it... Light layers... Additional lights, beautiful. If defined additional lights. Yeah, this one... Okay, so I still want to define these. So cell shade lit... We still want to do this, yeah. Yeah, we want to do all this. And then I wonder, it would be very nice if we could rely on this one. So I'm gonna see if that's possible. Universal fragment PBR, I think it's this one I want to rely on. Universal fragment PBR input data, ooh. Still input data. And then we have albedo, metallic, specular, smoothness, occlusion. Deprecated, use the version which takes surface data instead. Could use this one as well. Universal blin font. If I want to experiment later on with how I want the visuals to look, I mentioned earlier that I want the visuals of the environment to be somewhere in the middle of the spectra between purely cell shade and physically based rendered. So somewhere between those two. So right now when we develop this grass shader, we're going to start with universal fragment PBR. Use this one if it's possible. We'll see. But later on when we're experimenting, I might use this one more. Also deprecated. What's up, Major T? Showcase your game. Every day you spam my YouTube home screen with your stream. There really isn't that much to showcase right now. I'm sorry. Come back in a year and I'm pretty sure I will have something amazing to showcase for you. I appreciate it, Major T. I appreciate it. Raiden Shogun, how many years you have been learning Unity? I started using Unity in 2018, I think it is. So I've been working with it for 5 years. Smack my peach, speaking of that, when we're starting to work on mechanics. I have a little bit of a schedule here to my left. I don't think I'm gonna show it though. But define mechanics for me. So attributes, part of mechanics. Action system, part of mechanics. Apparel system, maybe not mechanics per se. But okay, so something like this. I want to get this grass in place, and then I think we're actually gonna do, I want to say terrain. I'm gonna reinvent the terrain wheel. And when we have the terrain in place, then we can start on working on terraforming mechanics. That's one type of mechanic. We can also start working on the garden functionality. Depends on how you define mechanics. I was thinking more like the interaction with the creatures. Okay, so for that we need creatures. I haven't really decided yet if I want to do the terrain and garden before I do the creatures. But so we could actually add creatures right now. They would be static creatures, but that's okay. We're gonna have some of those because we do have an attribute and an entity system in place. And with our action system, we can actually interact with creatures we can pick up creatures, but that's pretty much it. But okay, short answers, make my page this year for sure. It's like in my mind, I have a pretty broad definition of mechanics, game mechanics. So in my mind, we have already implemented a few of them, but far from all. Okay, but I want to use this one. But to be able to use this one, I need to figure out input data and input and surface data. We don't have these anywhere here, I don't think. So the question is BRDF, debugging, global, real-time lights, ambient occlusion, debuffer. Could they be in BRDF? Maybe. And the only reason I think that is because we have I thought we had some maybe we didn't. Let's take a look. Shader library. Let's see what we have in this one. BRDF data. Surface data. Oh, it's probably in that one, right? Data. So here we have surface data. Albedo, specular, metallic, smoothness, normal, tangent space. Beautiful. 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 Emission, occlusion, alpha, clear coat, mask, clear coat. Fuck, do I want to rely on these? What more did we have? Surface data and input data. So surface data, input data. Would be nice if it was in something called input data, but maybe it's in input. Input data. Oh, position. Jesus. We don't have a lot of these as of now. Although I wonder, so universal fragment blin fong. This one takes input data and surface data, but my guess it doesn't use a lot of the variables. We can fix that. Vertex lighting. Baked GI. Real-time lights. Fuck, am I gonna solve this in a similar way? Let's see here. Lighting might just take my cell shade lit implementation and not truncate the shading. Although actually we might do this one, I think. Or that just calculates, let's see here. Let's do Blin Fong. Would be nice to be able to rely on Unity's implementation of Blin Fong. What do we have? Attenuated color, light color, distance. Oh, I think I do something similar like that. And then we do lighting Lambert. Attenuated light color, light, input data, normal world space. Okay, this is pretty damn nice if you ask me. I would love to be able to use this one without having to rely on input data and surface data. So we're gonna implement this, or like re-implement it, but we're still gonna rely on lighting Lambert and lighting specular. I don't care about this one, not right now at least. So we still need to handle this one. Okay. Okay, let's see how that would look. Let's do it in, we're gonna do it in grass shader for now. Procedural grass. So we need to include lighting. Wonder if we get Oh, yeah. Okay, there we go. Great. And let's implement it over the fragment shader. We're gonna add related. And let's do half 3 is probably sufficient, but let's go with float 3. Calculate blin fong. Light. And we don't want input data or surface data or anything like that. Instead we do want the light. Okay, we already have that one. We want the float 3 normal in world space. So this is pretty much what I did in the cell shade lit, but instead of doing like this and this calculations myself, I'm just going to rely on the implementation in Unity. So I'm talking about skipping doing like these calculations, getting the specular term, the diffuse term, like this. Instead we're going to rely on lighting Lambert and lighting specular. So normal world space, speculoos map, specular color, surface data, we want smoothness. It's gonna work great together with, like if it rains, we want the grass straws to be have more specular highlights. So making this bigger or increasing this one. View direction world space as well. So we're gonna put this one here, float 3, view direction world space. I think we can calculate this one in the vertex shader. And what more do we have? Half for specular, and we also have smoothness. Specular here, we need as a 4. The fuck, half for why? Surface data specular as a, so I'm guessing it's a half 3 for some reason. I find this one to be a little bit weird. Lighting specular. Let's see. Lighting specular. Do we have an implementation of it? Here we go. Specular half 4. Oh, yeah. Oh, okay, I get it. So it's actually a specular color. So if we want specular color to have, if we want specular to be of another highlight color or another color than the actual material. Okay. Gotta have those glints. So we want that one as well, but we're gonna do it as float 3 specular. So now my question is, like we do this for each light, but then we have to add it all together. So light diffuse color. Light specular color. In the case of wet grass, what are we talking about? So, oh yeah. So for the grass, that's definitely true. That is definitely true. So this is a little bit more general. We could call it wetness, and keep it as a float. That's for sure. I will see. I want to keep an open mind. Maybe we will use the specular for more things than wetness. Who knows? You never know. But what I'm thinking of is, do I want to send in the albedo color here? So we calculate this and return it, or do I want to just return? Because we want to add multiple lights as well. Fuck it, this is a light diffuse color is a 1/2 so I guess this one is a 3 as well. So let's do float 3 albedo. So in this case it's going to look like or actually here I can just do, so we need this line, light diffuse color, light direction, input data normal VS. Here we just say normal VS instead. Light specular color. Oh, I do recognize this. And then we do this. But I think I want to do it. Yeah, we want to do, is this a 1/2? And I think I want to keep this one. So we do a few calculations up here, then we do light diffuse color, and then we do light specular color, and we're just gonna put it like this. I don't care about this. And what do we do here? Attenuated light color, light direction, normal VS. view direction vs half for surface data specular. Here we just do specular and smoothness. Okay, so now we have those two. And then we just return this. So we don't care about alpha here. So maybe in the future when we're working with a texture, we might need to, or if we go a texture route, so we generate grass straws and color them by texture with alpha clip, then we might want to think about implementing this, I think. But now we're just gonna do return light diffuse color multiplied by albedo plus light specular color. Calculate blin fong. Calculate blin fong using the calculate using a pre-implementation of the calculate blin fong function in lighting dot HLSL, but let's copy this function in shader library lighting HLSL. But without reliance. Or but without what is it? Why can't I find it? Input data, and we had surface data as well, right? But without depending on the input data and surface data structs. Right? Pretty. So when we calculate the final grass color here, we're gonna do a few things more. We're gonna do shadow and everything like that soon as well, but we're gonna do light, get main light, calculate cell shading color, but not entire like this. We're gonna do like that, and we're also gonna do this. And 400 lines. I think this might very well be the biggest file in my game, or like when you measure when biggest refers to number of lines. Get main shadow cord. Do I want to do that now? Okay, let's do it. Clip pause, input position, we use compute screen pause, shadow chord, great. Input view direction. Okay, I must see here. What do we have? We don't have. What do we need? We need albedo. We're gonna go with grass color there. Is grass color a float 4? Yes, it is. Normal world space. We have this one. We don't have this one. We're gonna have to send this one through the full pipeline, I think. So view direction. It's gonna come along for the ride. Same with now specular and smoothness. We just do as properties. So boop. Let's do do I want to call this grass properties? Grass proportions properties. Yeah, maybe. I should be able to use it anyway. And we want smoothness. Grass smoothness. Float. And specular. Color. We want to add grass and grass here, I think. Okay, so that is this one and this one. Albedo we have. View direction world space as well. So let's just copy how that is done in my cell shade lit. So we have okay, we do it here. View direction VS normal 2. So we calculate it in the vertex shader and then we just send it onwards. We do safe normalize world space camera pause minus. Okay, great. So let's take this first of all, and we want to do it in the vertex shader. And do I want it here? What do we need? Yeah, let's keep it there. Okay, so it's gonna do vertex shader output. Nah, I want it after the normals, but before the UVs. I think that's a better way to put it. So it would be not here, but here. 3, and it's view direction in world space. And we use normal 2. And then we need this one here. We need it here. And finally we need it here. So we calculate it in the vertex shader. That's okay. And then we go to the hull shader, and here we just need to send it onward pretty much. Right now, at least. View direction. Maybe I can just... We don't want to do anything here. Domain. Okay, so here we want to do we actually want to do barocentric coordinates for this one? Probably. Okay, and then we have the geometry shader as well, so I think we want to do this here as well. Oh, fuck, and then we want to send it onwards here as well. Jesus. Position. Although... No. Oh, fuck, I'm a little bit... Oh, I don't remember. I know there exists a reason why we do this here instead of in the fragment shader. Would be way nicer if we could do it in the fragment shader, however. View direction. Oh, what was it? Fuck. Actually, am I... View direction VS. Okay, so this is the view direction VS for our... We don't want to do this for VS, I don't think. So here we want to send in... So here we want to do U view direction world space is equal to input 0 dot view direction world space. Here, here, and here. But for these we want to recalculate it like Whoa, this is not world space. The fuck? This is TS. But I want this one. This. I want to use this one. So float 3 position right world space is equal to float 3 position left world space is equal to and then of course we want to transform it from world to clip, both of them. But we also want to use this one as it's going to be O dot view direction VS. Here we want to do, I think in the geometry shader, we want to do what we did in the vertex shader previously. So we want to do this again. Pretty sure. But we want to do, so view direction VS for this one is safe normal between world space, camera position, and not vertex input position VS XYZ, but position right world space. And we want to do this here as well, but with position left world space here. Does this feel natural? Val can't. Let's see here. There's a link I always, a bookmark I always share when I get a similar question. Let's see if I can find it. Okay, so it depends on how you want to. So, do you have any tips on how I can best learn Unity shader? I don't just want to watch tutorials and copy everything. I also want to understand what's going on myself. So, the way I like to learn is that I decide on something I want to do. So I need this for my game, and then I start implementing this for my game, and then I learn while I'm implementing that one. But I've also, it's a little bit hard to answer this question rightfully because I started learning shaders on university. But I also this, I don't know how to pronounce his name, but Cyan Lix or something like that. He has so much good and thorough information. So if you want to understand what's going on, I really recommend reading his stuff. And he actually has a few tutorials as well. I haven't followed any of his tutorials, but if they are anything like his write-ups when it comes to writing shaders in URP and stuff like that, I'm pretty sure he thoroughly describes everything that happens. I guess that's the best tip I can give concerning that. But I do definitely relate. I had a short period where I wanted to learn something, so I just watched tutorials and I did exactly what they did in the tutorials, and you don't really learn anything by that, you just mimic. Unless you actually stop and analyze, etc. But what I've noticed is that when I want to implement something for my games, or I want to implement something myself, I usually want to implement it in such a way that it differs quite a lot, or at least a little bit, from the things you can find in tutorials, which means that I have to learn what is actually happening in tutorials to be able to divert from them. But yeah, so yeah, good luck. And it also depends, I've noticed, on tutorials. Like, some people write tutorials in like, do this, do this, do this, do this approach, while other people write tutorials like, this is what we are going to do, and this is how you do it because of X and Y, and so on. Okay, so let's see if this is... I think this is the correct way. So when we actually start generating vertices in the geometry shader, we want to recalculate the view direction based on the position of these new vertices. So this means that we now have a view direction world space down here, so we can focus on this one again. Get main light, calculate cell shading color. Yeah, we want to change this one. So it's going to be color here. We're gonna... What's up, modding Minecraft? We're gonna start calculating the color, but we're not gonna do it by cell shading color function. We're gonna do it by calculate blend fong. And what do we have? Input dot albedo. No. Sorry. We're gonna go with grass color dot RGB. The light is going to be light. Normal world space input normal VS. Input view direction world space, and then we have specular and smoothness as well. So let's do like this, and they were so specular, grass, specular. Did I? Yeah, this one is a float 4, so let's do RGB here as well, and finally grass smoothness. So now we calculate the color for the main light, and then we want to get like how many additional lights are affecting this fragment. And this one is thanks to the Unity library. It's just a very good function from the Unity library. Same with this one. I'm pretty sure they are in here, but we're gonna have to find out. Yes, so then we get additional light based on position world space for the fragment. And yeah, of course, this is something, if I remember correctly, this is for baked lighting. I'm not entirely sure, however. But so we calculate color from the main light, and then we add the color from the additional lights. A little bit worried about... it should be okay. So we just want to do this again. With all arguments the same except for this one. Actually, all arguments are the same. It's only that we have changed this one before we send it in again. And that should be it. So let's see if we get something of value here. Color and 1. Okay. 406. Oh yeah. What do I want to rename it, and how do I want to rename it? go exp. Or actually we could just do, I think we want to do like this. Yeah, a lot of wrongs here. So it's not it's far from good. The question is, where did we go wrong? What do we have here? Grass top color or grass color. Smoothness 1. View direction seems to be messed up, I think. And I have no idea what happens here. Oh yeah, of course. I'm a little bit tired. We need to do this still. So that's one issue at least. Normal VS, so we want to work with normal VS instead of input normal VS. That should fix most of the issues. Yeah, the specular color seems to be fucked up as well. Specular color. And this is weird. What? Okay. It might, could we actually do all of these. Main light shadows, shadow soft. Whoa. We don't use. Whoa. Okay. Position world space. For the generated vertices, we don't set this one, so we need to do that as well. Position VS is equal to position right world space. So that's one thing. That might very well be the Still wonder why this happens, the flickering. What's up, Unscripted Logic? How are you doing today? And how's the physics-based game prototype going? I'm doing fine as well. A little bit perplexed by my shader here, but okay, so the shadows are fucked. We can shadows are semi-fucked. We need a few more things here. We don't have world space here as well, so let's do position world space is equal to position world space. Two, one. Oh no, position. Better. Way better. Way better. Yeah, I actually know about that. I did a sneak peek before my stream today. Yes, we're trying to do some nice grass shader. Something seems a little bit off, doesn't it? When it comes to a specular color, I think. Shadow works pretty nicely right now. That's nice. Shadow looks amazing in this grass. Although I want to get... Let's skip the specular highlight for now. I want to see if the diffuse is okay. So light specular color. Let's just do like this. This doesn't look correct. Although, fuck. Do I want to skip shadows as well? Maybe I do. Or not. Attenuated. So it's this one. Let's skip this as well. So no shadows for now. Yeah. Then. So the diffuse color is fucked. Okay, so for one side of the grass we don't have any lighting whatsoever. This is weird. Yeah, I recommend it on Scripted Logic. It's extremely fun. A bit annoying as well, but you know. So what do light diffuse color? We only use this one right now, and albedo, but this one is static, so it's we don't care about that. Light direction and normal world space. Is my normal in world space still fucked? Normal VS is facing input normal minus normal. Definitely seems like it. It's pretty much, yeah, it's pretty much only this one that can be wrong in this term. Or, yeah, we don't use view direction here. I really thought we had the normal under control. Normal random bend. Is it correct if we don't have any bending at least? If we do bend 0? No. Or... Okay, I do want to get to the bottom of this. This doesn't make much sense to me. It feels like it's like, so basically what we're seeing here is that we don't get any light on one side of the grass. So each grass straw always has one side that doesn't get lit, I think. Let's keep it, let's move down the subdivision to just one so it's easier to see. And yeah, so one side of the grass straw is always pure black, and it seems to be like not based on world position, but rather local. Okay, let's just jump to... I want to see, can we go... Okay, I can't jump to definition here, but lighting specular. Ooh. Now we do that. Lighting Lambert. Let's take a look at this one. Oh, it's so simple and clean. Normal, light direction, saturate, n.l. How? So the only possible reason for this one being screwed up is this one, right? So the normal we send in. I.e. the normal we create here, but if we do return norm float for normal world space 1 like this, it looks to be correct. So I don't know. Actually, blue, red. Yeah, it looks to be correct. Do we need to normalize it or something like that? That might actually be a problem. Let's take a look. Frag and normalize. We normalize the normal world. Okay, we might want to do that. If I remember correctly, do we do anything with views? Yeah, we normalize view direction as well. Okay, that's good to know. It's very good to know. Let's try that then. Procedural grass, normal VS. We also want to normalize this. Let's just do normalize. Normalize. I really hope this is the problem. It's one of the problems at least. No, it's not. Okay. Like the light calculations we get on these grass straws are pretty much. So what it looks like to me is that the lighting is calculated in the local space of the grass straw. So we're working with a normal that is not in world space, but. Can we see the main color or directional light? Yeah, so it does affect it, the color of this one. That's good to know. Am I doing something else here that I'm not doing in? Is this one screwing with me? I don't think so. Do you want to normalize it? Should be, I think. But do we actually need to normalize it again? Maybe we do. Maybe we do. But we do maybe we do. Pretty we normalize it here, but do we need to, maybe we need to normalize it outside as well. It should be okay, I think. Albedo, light, normal world space. Jesus. Light diffuse color, what do we do here? Attenuated light color. So this is just light color. Light direction. And normal. Yeah, it's just a... What is it? A light direction dot product the normal, right? This is the only, unless, do we get the correct light? I'm pretty sure we do. pretty much has to be this one. Jesus, this is annoying. I want to see. Let's take a look at if we return color here. Do we get? 373. Okay, so it's most of them are black when it gets to this direction. What does that tell me? What does that tell me? And this one is generated the wrong way. That's like that's the only thing I can possibly see being wrong. Although I don't know. Random rotation on the normal though. Does that screw it up? I don't know. Very weird, because if, like, I've tried this multiple times, but if we return normal world space, like, these are the correct values, why? They're normalized as well. Shadow chord. Are we calculating this the wrong way? Compute screen position from clip position. Transform world to age clip. Input position VS. This one is correct as well. But if it's clip position we want, why don't I... Shouldn't we be able to do... Similar result. And this is the weirdest part, like it's in this direction the majority is black. I don't know, I don't get it. But we should be able to do this here, pretty sure. World normal blue here. Like, or am I doing something wrong in my test shader here? I'm pretty sure I don't. Normal VS, no. Grass color is gray. Grass bottom color, we'll not use that one at all. these values, they make so much sense to me. I just don't understand how, like, normal values like that can become black on one side only thanks to these lines here. Doesn't make much sense. Why? Actually, it does make sense, and I'm completely out of my mind because I think this is how we want it to work. Like, the sun is there. Jesus. So the diffuse color does actually work. Although, like, yeah, it's aggressive as hell. But still. Wow. This reminds me of the other day when... Oh yeah, well, when we generated grass straws on the first vertex of each triangle, and it took me like 1 hour to realize that we could just put it in the middle of the triangle instead of changing how the mesh is rendered. Okay, so I'm pretty sure normal generation is okay. Good. So let's see here. I need to normalize float 3 view direction vs is equal to normalize input dot view direction as well, and let's send in this one instead of input, like that. Okay, let's add back this component and see how it looks. Actually, first I'm going to add back the attenuation. So we change, or we calculate how much the light affects the pixel by distance, and we also take shadow into account, which should, yeah, we don't do that. Yeah, we do it here. Okay, so this is one issue as well. We don't have, I think we should have shadows here. Or no. Okay. Yeah, we don't do any shadow drawing just yet. Ooh, I wonder how that will look. So we can cast shadows on here. Okay, so this is good, this works. But the grass straws themselves don't cast any shadows. I think that should be as easy to fix as adding a pass, like this. So we want to add a pass, a shadowcaster pass. It's just that okay, let's see if we can make it so we don't want our geometry shader to be in a pass or in a HLSL program tag, or whatever it's called. We want to make it such that, like, we want to include that in LOD. I want it in the subshader, right? Subshader HLSL include. So I want to do let's do cull off here, set test. Yeah, if we don't write anything, if we don't state this one, I think this is the default one. And then we want to go HLSL include here. And finally a end HLSL. And in here we want to put everything up to the fragment shader, I think, because then we want to split the fragment shader, we want to split into different passes. I'm pretty sure. Do I want tags here? Okay, pass, tags, and all of this. Yeah, let's put these. Yeah, let's put all of this in HLSL program. Let's take fragment shader related. Okay, so let's take all of this and put it in here. So HLSL include. So we're gonna have multiple passes in this shader, but it's pretty much only the fragment shader that is going to be different between the passes. So everything that will be the same between the different passes, we just put it in HLSL include here at the top. So we do all of this, and then we start a pass, and we name this one. I want a name here. Anna's error, thank you so much for follow. What OS I'm using? Windows. Oh yeah, I want to add a name. So, okay, so let's call this name procedural grass. Is this? Yeah, and we're gonna do color for this one. And then we can skip this, I think, and then we just add a function like this. Do I want to? Maybe I want to just tab this into one like this. 500 lines, closing up on 500 lines. Sick. where to find a good wallpaper for my computer like yours. Have I even showed my wallpaper? I don't think I have. Okay. Okay, let's see if this works so far, or if I've screwed something up. It seems to work, right? Beautiful. When you calculate the lighting for grass, you usually want it to be... Jesus, how tired was I? For some reason I thought the sun was coming from over here, but yeah. Okay, so it still works. Let's see if we can make the grass straw shadow the other grass straws, and it should be... So now when we have it like this, we should be able to just take this pass. Is it this one? Yes. Add another pass. This is going to be way simpler. So this one is going to be procedural get grass shadow caster, light mode universal forward. No, we're going to go with shadow caster. Oh, I mean light mode shadow caster. We don't need this function for this one. Fragment. We don't need this. Like this part is magic to me. Like making the shadow fragment. It's insane to me. I guess Unity does a lot of stuff under the hood here. Let's see if it works before I start praise it. Yes, it does. But yes, we have a few, or quite a lot of artifacts here. But that's probably more related to the settings here. Settings, rendering, or I hope it is. Is it depth bias? Okay, so what worries me most is this here. I thought it would be depth bias or something like that, but doesn't seem to be the case. Do we have another setting here? Baked shadow angle. Real-time shadows use settings from render pipeline. Near plane. Yeah, we do. Very annoying. I was pretty sure that this was a depth bias problem or normal bias, but okay, it's less apparent like this, but still. Okay, I'm just gonna try and ignore that artifact for now and continue with the implementation. Okay, very nice. So grass lighting. We haven't tried the specular just yet, but shadow casting and shadow receiving works. Let's take a look at the specular then. So calculate Blin Fong here. Currently the specular color is commented out. So let's go like this. Do we have a high value of specular right now, or is... Definitely seems like it. What do we have? Smoothness 0. So this is 1. It almost feels like it's the other way. There we go. So if we do... Okay. This much lighter if we remove the specular term. Maybe. Maybe. But actually, I'm not entirely sure this is the correct calculations. It looks wrong. Like if we have a smoothness value of 0, we're still getting a specular highlight. I don't know how visible it is. And that doesn't feel... This doesn't seem correct. Lighting specular. View direction, specular. Oh, whoa. This one. Smoothness is 0. I want to check lining specular. Specular and smoothness. Let's see. So what if 0 and pure black? Okay, then we don't get it. Okay, so the specular color still does what it wants. Okay. That's nice. It's still apparent. What the hell is going on? Or this might actually be... something here feels wrong. I need to double check this. Not entirely sure about this one. specular RGB times modifier. Modifier is just n.age. Okay. I think it's correct, but it does result in a pretty weird behavior, I think. I want to check. So if I do subdivision 3 like this, and if we go, it looks like it's shining, right? I want to check if it actually is. So let's remove the specular color again. Okay, so this is not. What the fuck? Wonder what it's related to. Is it just related to how the grass actually looks? Yeah, I think so. So we don't see any shadows on that one. Okay. Ah, great. I'm happy with that lighting setup. So let's see. Lighting, correct. Ooh, I want to add fog as well. So let's take a look how this material looks if we add it to the terrain. Prototype blue material. So let's do okay, so the terrain itself subdivides, so we can see that we have extremely few. The further away that's why we get this artifact right here. You can see this square, these lines. It's because the terrain itself actually subdivides. Let's see here. Grass height, let's go with 1. We don't have any grass. If I do, actually, what did we have? Okay. I want to try. I want to change a lot of things here. So we're gonna do a duplicate the material, and when it comes to terrain, we're gonna add the duplicated one. So this one, and let's make some weird changes. I want to change the width of the grass to be 0.1, 2. Like I want grass to appear in the Does it appear? Okay, I think we have some small grass over here right now. Hard to see, but yeah. Ooh, we cast shadows on the back side of grass. We need to check that one out. That's not a thing we want. But okay, I want to add fog to the color of the grass. So we can see here. Let's just take a look at cell shade lit again and see what we have. Cell shade lit. We have some fog related stuff here. We have if fog flag color add fog. We're gonna do add fog anyway. What do we need? Position in view space. Should probably calculate this one in the fragment shader. Or but yeah, let's copy add fog here. Procedural grass. Calculate blend fog. Add fog if defined fog fragment. Yeah, we don't need this one. Actually, fog fragment. Or do we? Fog fragment. Okay, we do. What do we have? Color and fog chord. What is this color? Okay, so that's the color we have of our object. And then we have fog factor. The fog factor in question. Oh, no, we just send in fog chords. Okay, so what are the fog chords? That's the position in the Z position view space Z component. Okay. So here we do Unity, calculate. We do have position in world space, so it should be easy to get position in view space. World to view, Unity HLSL. So it's probably M object to world V world to view. So it's this matrix. I'm not entirely sure I can get this one though. Let's see. So it should be as easy as doing mul Unity matrix V input dot position world space. And then we just take the Z of this one. Let's see if we can fetch this one. 464, yeah. Okay, we'll return color here, so let's do add fog color matrix V input position world space, and we take the Z of it. So project params. Are we missing? Oh yeah, we're missing a few things, I think. We're missing. Are we missing a pragma? Declare. Let's see. Is it this one? Compile fog. Yeah, I think so. Do I want to do it here? Beautiful. And I think that should be correct. So if we compare the shading over here to prototype material here, not that one, this one, it looks to be, it looks correct, right? Yeah, I think it does. Yeah, it does, it does, it does. Nice. What is happening here though? Okay, this doesn't feel very good, does it? It feels like we're adding shadow or fog here when we shouldn't. Do we have the same problem problem with that one. Okay, so something is wrong with the fog calculation, that's for sure. How unfortunate. Thought we had it. Okay, so this one is wrong. Using this one as fog chord. That is interesting. But okay, let's see this one. 2021. So we want to calculate fog chords in the vertex shader. Compute fog factor. Very interested in this one. O vertex Z. And vertex here is what the fuck? So just take the Z position of the vertex and compute the fog factor. I don't know about this, but I want to try it, that's for sure. What's up, Cooler SK, and welcome. Compute fog factor. Let's see if we get an error if we do. Ooh. Oh, it would be so nice if this was the only. By the way, did you watch the videos? No, unfortunately I didn't have time yesterday, but I think I will do it later today. So ask me again in 20 hours. Okay, let's try to compute it that way. Starting the timer, nice. So let's try and do it this way. So I need... So this is one other thing to keep sending on. Although... Okay, let's do... I should be able to do this in the vertex shader. So this is just the vertex position in object space, I think. Or is it? Let's see. No. O vertex. It's the position in clip space. Compute fog factor. Position in clip space. Beautiful. Let's try it. So basically we want to do, instead of add fog here, we want to do color is equal to mix fog color, and then we have the fog factor, and that is going to be compute fog factor input dot position cs dot z. I don't know. Seems too easy. A bit too much fog, I think. I wonder why it's so... Yeah, looks like a different planet, right? I agree. But, so this one seems to be wrong. Mix fog. Compute fog factor. But, okay. We do it in... I don't know if it's... Oh, I don't know if it's any difference here. Like, what if we just use this one? Nope. Compute fog factor. I'm extremely interested in this one. Although I wonder what input. What do we have? Lighting. Let's see. Compute fog factor. Calculate final color, lighting data, fog factor near to far said. Okay, so this is what I used previously. And here we do the fog chord. But the fog chord in question, what is that one? Calculate final color. Okay. Calculate final color. Are we calling this one from somewhere. Return minimum, calculate final color, lighting color, surface data alpha half max. The fuck? What's up, modding Minecraft? What am I doing? I'm trying to get fog to work with my grass shader. But I wonder if I want to do compute fog factor. Maybe I want to do add fog like this. No, I don't. Okay. Input data fog chord. It shouldn't really be a difference, right? If we calculate the fog chords in the vertex shader. So calculate the position in clip space here, and then we use this one to calculate the fog chords. We do get some interpolation. Is that wrong or not? Okay, let's try it. So let's do, just want to double check this. Geometry shader output. Let's add float fog chord. It's text chord 1. Okay. Chords, text chord 1. So geometry shader output. Is equal to compute fog factor, and then I guess it's o dot position cs dot z. Okay, and then we need to do it here as well. I don't really think there's that much difference doing it like this, but I want to try. I'm not going to rule anything out. Color add fog, color, and here we want to do input, or actually not add fog, but mix fog. And here we just want to do input dot fog chords. Jesus, sometimes like shaders, I don't get it. But do we get the same issue here? No, I don't think we do. Beautiful. So my guess, can I riff? Let's see. I just want to double check. The gradient we get about here, does it look similar to, yeah, it does. Okay, so that's the shadow in place. I want to fix it for my let's see here. Fix fog calculation in cell shade lit. So there's, if we do the fog coordinates, if we took the clip space here and tried to change it using compute fog factor, we didn't get a good result, and I wonder if that's because of the interpolation that is being done on position clip space between or you might need to do this one before the fragment stage. That, like, this one might actually depend on stuff. Okay, so it's probably not this one that change. That is the cause of the difference. It's probably this one. I wonder. I would have liked to be able to see how it looks beneath. I would like to take a look on this implementation. The question is compute. We're gonna do some renaming here as well. I'm not a big fan of fog chords, I don't think. But I wonder, core and lighting. Let's take a look if we can find it. So this is lighting. What do we have here? We have BRDF, global illumination, real-time lights, ambient occlusion, debuffer. BRDF. Go to the file. Do we have any fog here? Let's not worry about that one right now. Research. Research, such a fancy word. Research tangent space, specifically in Unity. I want to understand that more, and I also want to do research compute fog factor. Okay, so we're gonna change the name of this one to fog factor actually. It's very nice that we don't need to send it all the way down. I wonder... Yeah, so instead we just introduce it in the geometry shader output. I think that's okay. Fog factor. Text chord 1. Do we have something better for this one? Let's see. HLSL properties or whatever. What's it called? HLSL text chord. Semantics. Float blend weight. Point size. Fog. Vertex fog. Can I use this one? That sounds like it's like it was implemented to be used for this, but output. Output, okay. So the only float we can use are size or blend weight. V face. Let's use text chord 1 fog factor. And then we don't need all of this. Instead we just do this. Beautiful. Nice. Okay, actually, can I might crash things now, but is there any way that we can do terrain here? Can we disable LODing? I don't think. Unity disable terrain LOD. Changing the LOD settings on terrain. Base map distance, but isn't it base map distance? I don't think it's this one. maybe this is not possible. It's mostly like the banding effect we see here is because of scene. Wish I could. Yeah, the further away we are from the terrain, like it renders with less vertices, which is nice, but it screws up the visuals of my grass right now. There should be a setting for this, I think. Boom, 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 boom. It's not this one. It's very apparent when we're working with shadows, but not as apparent in this direction. And also, do we have this line here is extremely weird. I wonder if these lines are also related to the terrain mesh or not. Wow, so many optimizations are being done to the terrain. Although okay, let's add back this material to that one. Let's take this plane and see what more we can do today with it. What more we need to do. That's an extreme lot. Grass subdivision 1 for the, or actually grass subdivision 8 subdivision 1. Okay, this one. I don't know how much I will be able to do on this one today. But guess I can start at least. So, the simplest way would be to just base the color of the grass on actually, we need to add one more thing here. Grass root make grass root vertices or vertex normals align more with ground. So that's one thing we definitely need to do, and what that is going to remove is this line we see here. So right now the ground using this plane has a normal of world up. This grass has a normal pointing in this direction. So you get this sharp shading here. So if you would, for instance, we're gonna do one more thing, but if you would, for instance, make the ground here have a color of green, and then you match the color of this grass straw down here with the color green on the ground, you would still have this artifact here. You would still have a line here because it's being shaded differently based on the normal. But if we could take, when we generate the normals for the grass straws, if we could make the normals, like the closer it is to the ground, the more we make the normals align with the normals of the ground, and the higher up it is, the more we make it align with the grass straw itself. We're gonna add some settings here for that as well. So you pretty much want to, following the grass straw, you want to interpolate the normal between the actual normal it should have and the normal of the ground. And that will fuzz this straight line out a bit. So we want to do that. And that's this task. Another task I want to add is, where do we have it? Grass lighting, 1, 2. Let's add some sub tasks here, which some of them has already been completed. Add ambient. Is that what I call it in cell shade lit? No, diffuse. Ooh, might want to add diffuse lighting, add specular lighting, add rim lighting, add, oh, what is that one called? Specular rim. Oh, do we have it here? Let's see. Fragment shade ambient. Okay, yes. And I want to make the shadow less. I wonder if we can fix that with ambient. Maybe. Color plus equals ambient color times. Yeah, I want to add this one as well. Diffuse, specular, rim, ambient, lighting. Possibly on this one. I want to also add, like, grass straws are rather thin. So you want to make it look like the lighting is actually like you want to make it look like a big part of the lighting penetrates the grass straw. I don't know exactly how I want to achieve that, but I know that I want to achieve it. Okay, so how do I want to write that in my task? Add penetration lighting. I'm sure I will understand what that means tomorrow. So diffuse is done, specular is done, rim and ambient are still needs to be done. So color, let's take this one. Color. Wonder if we can do, maybe we can just do wow. Is this actually correct? No, this is probably not correct. Why? Oh, why? Ooh, we need that as well, maybe. Why are we getting such a light effect of this here? Should this be added previously? It might need to be added here actually. Light specular color, or is it already added in? Ambient. Or am I just adding it in the wrong way? Unity ambient sky. This is how I added it in the cell shade lit, and we get a pretty good result from that. Doesn't seem to be the case here though. Unity ambient sky. Am I missing a keyword once again? Maybe. No. Blin Fong ambient light. We have an ambient here. Ambient color. Color linear. Ambient color plus diffuse color plus specular color. It should be something like this. So why? Let's see here. Calculate cell shading color. Yes, and then we multiply. Okay. So we do it in a little bit of a different way here. So Unity ambient sky. Diffuse color. Or actually, I want to try. Do I want to add this? Maybe we want to add it here, but that doesn't make much sense either, does it? Then it's going to be extremely light, I think, or actually the same result here. Looks pretty good. So is it Unity ambient sky XYZ? Why does this seem to be extremely light compared to when I use it in cell shade lit? I should probably use some like ambient multiplier. I'm pretty sure this is the good way, like the way to do it. What do we have? Lighting, environment, real-time shadow color. 0.1. This is not at all how it should look, right? If we remove this term, grass color, or actually this might be the correct way to do it. Grass color, but okay, what do we have? Unity ambient sky, lighting, environment lighting, skybox, gradient color. Okay, so if it's skybox, if I do skybox prettier, let's change this one to don't we get the skybox changes but not the effect on this one? Does this even work? Let's see here. Unity ambient Okay, we're multiplying with a lot. Let's see. Okay, like this, and then we do exposure. That doesn't seem like it does. Get ambient light, custom shader 2022. There we have the fuck. I want to try that one. I'm getting a little bit of a deja vu. I think I've done this previously. Okay, this looks amazing, I think. This is correct, I think. But we don't want as much as this. So if we do grass this color. Okay, nice. And I want to double check it. So skybox prettier exposure. This one doesn't change it. Atmosphere thickness doesn't change it. Lighting, but this one does. Okay. Source, but it's weird. Okay, let's take a look again. Intensity multiply 1. So I want to check skybox prettier. Let's go sky tint red, ground tint red. It's pretty cool. Why doesn't it affect this one though? Interesting. Or do we need to skybox prettier, directional light, source skybox? Do I need to play maybe? It doesn't change it. Okay. That is weird. It does look a little bit blue, doesn't it? So let's continue. I want to try this one as well, but unfortunately I don't have more time today to do it. But still, it's starting to shape up. What did we do? So grass lighting, half of it is pretty much done today. That's very nice. Normal generation after a lot of struggling, it's in place. The fog and shadow casting and shadow receiving. I think it's pretty damn good. Might finish this shader this week actually. But that's it for today. So thank you so much everybody for watching, for following this struggle for the perfect grass shader. I will be back tomorrow, continue right where we left off. Yes, that's about it. Have a great rest of the day. Peace.